Hey, what's up everyone? Alex here with GMAT Ninja. Welcome to Statistics Part 2, another video in our Quant series. This one's going to cover standard deviation, mixtures, weighted averages, and percentiles. So if you're looking for the other statistics topics, mean, median, range, those are all covered in Statistics Part 1. Statistics Part 2, we're going to be covering those other topics. Now, most of our quant videos kind of progress from the very easiest questions to medium and then hard over the course of the video. This one's going to feel a little bit different just because we're jumping between three very discrete different topics. So we're going to start with two very basic standard deviation questions, and then we're going to have a challenging one. Then we're going to go back to kind of medium level mixture weighted averages questions, wrap up with a percentiles question. So although the difficulty of these questions varies, I'd say these are all topics that you want to be familiar with if you're shooting for an 80 plus on the quant section. Now, although it's a quant video, we do actually include two data sufficiency questions here, and that's because these statistics topics show up fairly commonly on the data insight section, so we wanted to make sure you're covered with two data sufficiency questions. And the way it's going to work is we're going to put a question on the screen for 2 minutes. If you need more time than that to solve it, feel free to hit the pause button, and then after that we're going to work through a solution, show you an efficient way to work through these. All right, well, let's take a look at that first question.
Hey everybody, Charles here. Sorry for the interruption. Before we get you back to that quant content, 3 quick things I'd love for you to be aware of. First of all, this video is part of our full, free, complete GMAT course that's available up on our YouTube channel. If this course is saving you money that you would otherwise spend on a course or a tutor, please consider donating some of that savings to charity, either a charity that you love. If you don't have a charity that you love, we've got a list of charities that we love to support on our website, gmatninja.com. Second thing, if you love that presenter that you're watching in this video, not me, the other one, they offer one-on-one tutoring. If you're interested in that, gmatninja.com and we can set you up. Third thing, finally, if you're doing great on the GMAT, doing great on the GRE, starting to look for admissions help with your applications for grad school, we would love to refer you to a bunch of our favorite companies. So just hit us up. There is a contact form on our website, gmatninja.com. Also, a link in the video description. Just fill that out. We'll send you a list of our favorite admissions consultants, not just at our company, no strings attached, not going to sell your email, not going to try to sell you anything. We just want to make sure if you've put in the hard work on the GMAT, that you end up in the best possible hands if you need help with your applications. All right, that's it. Enjoy the quant.
All right, so before we dive into this question, just a reminder that the first 3 questions are all going to be dealing with standard deviation here. Now the first 2 are just really vehicles for dealing with the fundamentals, basic concepts, so nothing all that fancy or challenging going on. Then when we get to question 3, that's going to ramp up the difficulty a bit and kind of show you, well, what sort of logical connections does a GMAT want you to make using these standard deviation fundamentals? Okay, so what are those standard deviation fundamentals that you want to know? Well, standard deviation is a way of describing a data set, a bunch of numbers, and it tells you, on average, what is the distance from the mean? So if I have a data set, this group of numbers right here, well, that group of numbers has a mean that I could calculate, and standard deviation is telling me, on average, how far are these numbers from that mean? In other words, how spread out are the numbers? Another way of thinking about standard deviation. So if the numbers are really spread out, on average they're really far from the mean, big standard deviation. If on average they're pretty close, the numbers are all clustered together, not that spread out, well, that's a smaller standard deviation. And really, that's the crux of what you need to know for standard deviation on the GMAT. Nothing all that technical, all that fancy. Those kind of qualitative concepts is what you want to know. So I put 3 and 4 up here, these formulas mostly as an example of what not to know. Sure, there is a formula I could use where I could plug in a whole bunch of numbers and spit out the exact standard deviation, but I'm never going to be asked to do that. I don't see this formula doing a whole lot of good for me on the exam. Same thing with this other definition of standard deviation. It's the square root of the variance, so there's a mathematical relationship between something called variance and standard deviation. But again, I'm not too concerned about that. Really, this is where the points are. If I know these, I can work with those concepts, I'm in good shape. So let's look at some examples of how that might work. And I was saying, well, you're not going to be asked to calculate the standard deviation, but I might be asked to make a judgment, well, between two groups of numbers, two data sets, which one has a bigger standard deviation. So if I look at these two, I notice, well, they both have a mean of 3, but notice these numbers are more clustered around 3. On average, the numbers are closer to 3. Here they're a bit more spread out. So between these two, this one has a bigger standard deviation. Okay, so that's the sort of judgment you might be asked to make. And let me throw two kind of variations on that to push this concept a little further. So I'll make another data set which has 6 numbers instead of just 4. Now between these two, which one has a bigger standard deviation? Well, notice for this case, half the numbers actually are the mean. I've only got 2 numbers that are farther away from the mean. In this case, well, notice 2/3 of the numbers are pretty spaced out from the mean. So on average, the numbers here are farther from the mean. These numbers are more spread out. So between these two, this one has a bigger standard deviation. Okay, and I could kind of take that in another direction. So let me compare the top set to another group with 6 numbers. Okay, so between these two data sets, which one has a bigger standard deviation? And again, notice, well, they both have a mean of 3. They also both have the same range. But in the top data set, 2/3 of the numbers, right, 4 out of those 6 are actually sitting right on the mean. Those are pretty clustered together. Here, well, only half the numbers are sitting on the mean, right? Half of them are more spread out. So between these two, this one has a bigger standard deviation because the numbers are more spread out. Here they're more clustered together. Okay, so that's one angle on standard deviation. If I compare two data sets, could I make a judgment about which one has a bigger standard deviation? Now, I could illustrate that with a graph as well. I could also, imagine a math class that took an exam and maybe the average score was a 70, and maybe I'll say, okay, so this is scores down here, by the way. This is number of people in the class who got a particular score. And maybe 100 people got a 70, and a lot fewer got 60s and so forth, and a lot fewer got 80s and 90s, and very few even got 100s. Okay, so that's a data set right there. And I might be asked, not to be able to calculate the standard deviation just on that alone, but to compare that to, say, another class where, I don't know, maybe only 50 people got 70s and a whole lot more people got 30s and 90s and that sort of thing. So I could represent that distribution like this, right? It's also sort of a bell-shaped curve, but it's a lot flatter. And I'd want to be able to know, well, between those two classes, which one had a bigger standard deviation? Well, notice the red class, the scores are more spread out, right? On average, there's a lot more people getting 90s, a lot more people getting 30s. So the red class has a bigger standard deviation. Okay, so that's the sort of judgments I'd be asked to make. And one other element of standard deviation that I want to go over, and here's where I might actually have to do some kind of calculation. So again, that class we said the mean score was 70, and I'll just make up a number. Let's say the standard deviation was 10. So I might be asked about person A, who scored I don't know, how about 1 standard deviation above, and person B who scored 2 standard deviations below the mean. I'll put mean there for both those. Okay, so what did person A score if they scored 1 standard deviation above the mean? Well, the mean was 70, the standard deviation was 10, so this person scored an 80. Okay, what if person B, they scored 2 standard deviations below the mean? Well, the mean is 70, 2 standard deviations is 20, so they scored a 50. Okay, so those are the basic building blocks that you're going to want to use on GMAT standard deviation questions. So let's see, does that help with this particular question here? Okay, so I'm giving a data set with these different plants, and what am I told? Well, the standard deviation is 9, and I want to know how many of the 12 plants are more than 1.5 standard deviations above the mean of the 12 plants. Okay, so I'm going to want to find the mean of these 12 plants so that I can figure out, how far is 1.5 standard deviations above it. All right, so I guess I've got to crunch the numbers here. Let me try to find a neat path through them. Hopefully, the GMAT often provides a way to do that that's simpler than another, so I'll be strategic. 28 plus 12 is 40, okay. I guess 24 and 6, not too bad, that's 30. Okay, and how about 15 and 2 plus 3 is 5, so that is 20. Okay, and how about, let's see, 7 and 18, that's not terrible, so that's 25. Okay, and I'm just left with 21 and 8. All right, I'll suck it up. That's 29. So what have I got here? 70, 90, 115 plus 29. Okay, that's 144. Okay, and the only reason I go through all that tedious arithmetic is just a reminder, that's going to be an element most likely of your test at some point, but let me not rush it, and also let me be strategic about how I'm adding the numbers. Okay, so anyway, they add up to 144. I've got 12 of them. So nice to know the numbers are working out. The mean is just going to be 144 over 12. So that is equal to 12. And how many of the plants are more than 1.5 standard deviations above the mean? Okay, well, 1.5 standard deviations would be 1.5 times 9. That's 13.5. So 13.5 plus 12 would give me 25.5. Okay, so 1.5 standard deviations above the mean would be 25.5. So how many of the data points, let me read this, how many of the plants are more than 1.5 standard deviations? Well, how many are bigger than 25.5? Well, just that one there. Okay, so that leads me to the correct answer choice here of B. Okay, so what do you want to take from that question? Well, just to demonstrate the idea, there's certain standard deviation formulas that are great to know in other contexts, but not all that important on the GMAT. If I'm good with these fundamental concepts and know how to do some arithmetic with standard deviation and mean, that gets me a lot of mileage on this test. All right, great. Let's take a look at the next question. All right, so before we dive into this question, I want to deal with another fundamental concept about standard deviation, which is, well, what happens to the standard deviation of a data set, a group of numbers, if I perform some operation on it? So here's what I mean. If I consider a data set, let's say these 4 numbers, and as we were saying, I'm not going to need to calculate the standard deviation of this group of numbers, but it has some standard deviation. And the question would be, what happens to that standard deviation if I say add some number to every member of this set, or if I multiply every member in this set by a certain number, or divide or subtract, something like that? Okay, so let's try to answer that question, and we'll start with, what if I add some number to every number in a set? What happens to the standard deviation? So I'll add 10 to every number in this set. I'll get 14, 16, 16, 18. And now the question is, what happened to the standard deviation? Did it get bigger? Did it get smaller? Well, let me think. Going back to my basic definition, did these 4 numbers get more spread out than these? Did they get less spread out? Did they stay the same? And I quickly notice, well, they're about equally spread out, right? The gaps between the numbers stayed the same. 6 to 8 is 2, 16 to 18 is 2. I could say the same about the relationship of all the other numbers in the set. Really, all I did was take this group of numbers and shift them up, but their spacing didn't change. They didn't get more spread out, less spread out. They stayed the same. Okay, great. So the standard deviation of these 2 sets of numbers is the same. So that tells me, all right, well, if I perform the operation of addition or subtraction, I just shift a set up or down. I don't make it more spread out or less spread out. It stays the same. Standard deviation also stays the same. Okay, and I could represent that visually back to our class that had, say, an average score of 70 on a math test. And let's say, all right, I decided this test wasn't fair. Everybody, I'm going to add 10 points to everybody's score. Okay, so people who got a 70 now have an 80. People who had a 90 now have a 100. So there's the new graph of the class once everybody's scores have been increased by 10 points. And notice the shape of the curve doesn't change at all. Sure, it got shifted up. Everybody has higher scores, but they're not more spread out than they were before. So that just is confirming the idea, when I add, subtract, I don't change the standard deviation. It stays exactly the same. Okay, let's consider another operation. How about multiplication? What if I multiply all these numbers by 2? How does that affect the standard deviation? Okay, so same question, did they get more spread out or less spread out? Well, notice the gaps got bigger. This 6 to 8 was 2, 12 to 16 is 4. So things that were somewhat spread out now are more spread out. So that kind of tells me, okay, I think I answered my question. It got more spread out. Now, how much more spread out did it get? Well, I multiplied everything by 2. Looks like things got twice as spread out. So what's the result? Well, the standard deviation got doubled. Okay, so those are the fundamental concepts I wanted to add. I'm performing operations on a set of numbers. How does that affect the standard deviation? Well, if I add or subtract, if I shift it up or down, standard deviation stays the same. If I multiply, divide, something like that, well, then I'm changing the standard deviation. And how am I changing it? Well, if I multiply everything by 2, I'm doubling the standard deviation, and same for other numbers. Okay, so let's try applying that to this question here. So what am I told? Set A has a standard deviation of x. Okay, great. So I know my standard deviation, or at least I have a variable to represent it. X is my standard deviation. And this is for set A. Okay, set B, I'm going to take all the numbers in set A, have them, then add positive integer y. So what's the standard deviation of set B? Okay, so what's this standard deviation? Okay, well, let me just imagine a number in set A. I'll just say, okay, maybe set A had a number n. Okay, it has a bunch of different numbers. Maybe n is one of them. And what am I going to do to n and to all the other numbers? Well, I'm going to have it to make it part of set B. So it's 1/2 times n. And then I'm going to add it to positive integer y. Okay, so if I do that to all the members of set A, how is it going to affect the standard deviation? And as we said, well, if I add or subtract, I'm just shifting the numbers, so I'm not changing the standard deviation. They're not getting more or less spread out. So that's going to have absolutely no effect on the standard deviation. What about multiplying it by 1/2? Well, we said if I multiply a set of numbers by 2, I'm making them twice as spread out. I'm multiplying the standard deviation by 2. Same thing would apply to 1/2. If I'm multiplying all the numbers by 1/2, they're getting closer together by a factor of 1/2, you could say. The distances are shrinking by a factor of 2. They're half of what they used to be. Okay, so I'm also multiplying the standard deviation by 1/2. All right, so if my original standard deviation was x, adding y to all these numbers is not going to change it. Multiplying it by 1/2 is going to shrink the standard deviation by a factor of 1/2. So there's my new standard deviation, and the correct answer is C. Okay, so that wraps up the fundamental concepts that you want to know for standard deviation. How do I compare two sets and decide which has a bigger or smaller standard deviation? How does the standard deviation change if I perform various operations on the set? So with all that in mind, let's try a question that has a bit more challenge to it, and let's take a look at that one. All right, let's take a look at this one. Set M consists of 100 numbers with a standard deviation of 10 and a mean of 45. Set N consists of 4 numbers. If all of the numbers in set N are added to set M, will the combined set have a standard deviation greater than 10? Okay, so let me get down some of the key information I have here. I've got one set that they're calling set M, and it's got 100 numbers in it. And what do I know? Well, they told me its mean and standard deviation. The mean was 45, and the standard deviation was 10. Okay, now I've got another set of numbers. They're calling it set N, and this has only 4 numbers in it. But I don't know anything else about it. I don't know what the numbers in the set are. I don't know their mean, standard deviation. Just know that it's got 4 numbers. Okay, now I'm going to add all these numbers in set N to set M, create a combined set, and they want to know, is that combined set going to have a standard deviation greater than 10? So basically, if I change set M, I add some more numbers to it, what's going to happen to the standard deviation? That's what I'm trying to answer. So I'm asking myself, okay, well, is it going to make the set more spread out, less spread out, that kind of thing? That's this question seems to be getting at. Okay, so let's see if these statements help me answer that question. What impact am I going to be having on set M when I combine set N with it? Okay, so the range of set N is 0. Okay, so that means the biggest number in set N minus the smallest number is equal to 0. The only way that could be true is if I have 4 of the same number. Okay, great. So set N consists of 4 numbers that are all the same. So if I add those to set M, how is that going to change the standard deviation? Well, not knowing what those 4 numbers are, it's really hard to say. I suppose I could add numbers that are all really, really close to the mean, and that presumably would make the standard deviation smaller. I could add numbers that are really, really far from the mean, and that would make it more spread out. So just based on the fact that I'm adding 4 of the same number to a set, I don't know what impact it's having on the standard deviation. Is it making it more spread out, less spread out? impossible to say just based on statement 1. So, okay, A and D are gone. Let me consider statement 2 on its own. The sum of the numbers in set n is 180. Okay, so at least I have a number now, 180, but I quickly realize that doesn't tell me a whole lot about what those numbers are. Sure, they add up to 180, but I can imagine a lot of different cases. I can imagine numbers that are all super close to 45 adding up to 180. I can imagine numbers that are really widely spread. In fact, there's kind of no limit on how spread out these numbers could be, right? I mean, maybe one of the numbers is 1,000 and another one is negative 1,000 and another one is 0 and another one is 180, right? They place no limits on these numbers. Are they positive, negative? Are they integers even? All I know is that they add up to 180. I can imagine a whole lot of different scenarios, some making it more spread out, some making it less spread out. So I really can't say just based on statement 2, so B is gone. Okay, so now what if I consider both the statements together? So set n has a range of 0. I've got 4 of the same number, and those 4 numbers have to add up to 180. Okay, so that tells me 180 over 4 equals 45. Set n consists of the number 45 repeated 4 times. That adds up to 180, has a range of 0. Okay, so how is that going to impact the standard deviation? Well, I'm adding the mean 4 times. So what impact is that going to have? Well, the numbers on average are getting less spread out. On average, they're closer to the mean. Okay, and just to demonstrate that, let me go back to a kind of specific example we were talking about earlier in the video. Here's a set of numbers, okay? The mean is 3. What happens to the standard deviation if I add a bunch more 3s, right? It's kind of like what we're doing here. We're adding a bunch more of the mean. Well, now a bigger percentage of this set is equal to the mean. It's getting less spread out. The numbers are more clustered towards the center. So what's the effect of adding the mean a bunch of times? Like we were saying, that's going to decrease the standard deviation. So if I add four more means, 4 more values of 45 to set M, I'm reducing the standard deviation. So the combined set is going to have a standard deviation that's smaller than 10, right? I can't calculate what is the exact standard deviation going to be just based on that, but I don't need to. All I need to know is the set is getting less spread out, standard deviation is going down, so both the statements together are sufficient to answer the question. Okay, so what do you want to take from that question? Well, notice there's no fancy statistics concepts that I'm really needing here aside from what we've already covered, right? What is the basic meaning of standard deviation? What happens when I add numbers to a set or alter the numbers in a set? And if I keep those basics in mind, again, that leads me to the correct answer here of C. All right, great. So we're going to pivot to a new topic now, talk about weighted averages and mixtures. So let's do just that and take a look at the next question. All right, so before we dive into this question, just a reminder that we've pivoted to mixtures/weighted averages, just kind of two different ways of saying the same thing. And there's more than one way to approach this kind of question. It's possible to do this sort of algebra approach, but that can sometimes get excessively complicated. So there's a more conceptual way also to think about these that I think is a little bit more in line with how the GMAT thinks about them generally, can give you a nice efficient way to approach these questions. But we'll start with an algebra method, mostly just to kind of clarify and set up a more conceptual approach. Okay, so in company X, 70% of the junior employees and 38% of the non-junior employees received a negative performance review. If 42% of company X employees received a negative performance review, what percent of company X's employees are junior employees? Okay, so I notice I'm given two categories of employees, and those two categories have to include everyone at the company. And why do I say that? Well, by definition, if you have some job that's, you're not a junior employee, you have to be a non-junior employee. So that's everyone at the company. Juniors, non-juniors is everyone. So I could say J plus N equals T. And now let me try to count up the number of people with negative performance reviews. So 70% of the juniors, J is the total number of juniors, they have negative performance reviews. 38% of the non-juniors, so 0.38 of N. And if I divide that, the number of people with negative performance reviews, by everyone at the company, that's 42%. Okay, I'm trying to find the percent that are junior employees. So I noticed from this, I could figure out the ratio of J to N, right? I've got J and N in this equation. I could simplify it. If I know the ratio of J to N, I could find what percent are J's, what percent are N's. So I think I'm in good shape here. Let's simplify algebraically. I'll multiply everything by 100 to get rid of the decimals, multiply by J plus N to get rid of the fraction there. I'm left with 70J plus 38 N is equal to 42 times J plus N. I'll distribute the 42 to the J plus N. Okay, let's get all the J's on the left, all the N's on the right. So I have 28J equals 4N. Simplify that, 7J equals N. Okay, I want to find the ratio of J's to N's. So get the N over on the left. J over N equals 1 over 7. Okay, if the number of J's to N's is 1 to 7, then I guess J over total would be 1 over 8. 1/8 is 12.5%. Okay, so if any of that algebra there felt excessively complicated or just hard to follow, feel free to check out one of our ratios or other algebra videos that go through that kind of stuff in a lot more detail. But long story short, there is an algebra approach here, and that will lead you to the correct answer. But is there a more conceptual way to think about it? Well, I think the key here is to realize I'm dealing with a weighted average. More specifically, a weighted average of 70s and 38s, right? 70% is related to the number of J's, 38% the number of N's, the number of non-juniors. And just to take a step back, what do I mean by weighted average? Well, the average of 70 and 38 would just be 70 plus 38 over 2. In this situation, I've got a certain number of J's, a certain number of N's, and I'm averaging those, right? And you can see that in this equation. I've got J 70% and 38%, and I'm dividing that by the total number of J's plus N's. Okay, so long story short, that's the key here. Recognize I'm doing a weighted average, and it's a weighted average or mixture, however you want to talk about it, of 70 and 38. And I can use a barbell diagram now to work my way towards an answer. So let's explore how this diagram might work a little bit, and then we can go into the question itself. Okay, so I'm going to imagine a scenario. What if, this is the number of J's, the number of N's, and I have an equal number of J's and N's, okay? So I'm averaging 70%, 38%, and I've got an equal number of 70s, equal number of 38s. What would the average be? Well, it just kind of makes sense. It would be right smack in the middle, right? Both 70 and 38 are equally weighted, so the average will be right there in the middle. Okay, so let me imagine a slightly more complicated scenario. What if the number of J's was 3 times the number of N's? I've got 3 times as many J's as N's. Okay, so J is equal to 3N. If I know that, what's the weighted average going to be? Well, let's see. If J equals 3N, then I guess the ratio of J's to N's would be 3 to 1. Or another way to think about that would be I've got 75% J's, 25% N's. Okay, well, if I've got 75% J's, I've got a lot more 70%. The weighted average is going to be closer to 70. Okay, great. So I'll draw it right here. And then I might say, well, how much closer to 70? Well, if j's to n's are 3 to 1, it's going to be 3 times closer to 70 than to 38. Okay, so let's put some numbers on that. The total distance from 38 to 70 is 32. Okay, but j is 3 times closer, so this distance to this distance will be 3 to 1, or you could say that this is 75% of the distance. 75% of 32 is 24. That leaves 8 here. So the weighted average is 62. So again, what I did there was I worked from the ratio of j's to n's, said the weighted average has to be closer to 70. I know how much closer, and I can pin down an answer there. And I could have gone the other way too. For instance, if I was told the weighted average was 62, by a similar method, I could work my way backwards and figure out the ratio of j's to n's was 3 to 1. Okay, cool. So now, before we move on, you could notice a lot of ways that the GMAT could play with this idea, particularly on, say, data insights, data sufficiency. For instance, well, I don't necessarily know the number of j's and n's, but if I know the ratio of j to n, that's sufficient to figure out the weighted average. Or going the other way around, if I know the weighted average, sure, I could figure out the ratio of j's to n's, but it's not sufficient necessarily to figure out the number of j's, the number of n's. Okay, cool. So let's try applying this to this particular question. And again, we're finding the weighted average of 70 and 38, and we know that weighted average is 42. Okay, so can we go from the weighted average to the ratio of j's to n's, and that should lead us to an answer. Okay, well, the weighted average is 42. So I'm going to have more n's than j's, I know that much, but how many more? So I can figure that out by looking at these distances. This is a distance of 4, 38 to 42. 42 to 70 is 28. Okay, cool. So 28 to 4, that gives my ratio. Now, which does the 28 go with? Does 28 go with j's or n's? Well, the fact that I am closer to 38 means I have more n's. So the n corresponds to 28, the j corresponds to 4. Okay, and so simplify that. N to j is 7 to 1, or to flip it like I had with the original algebra, j to n is 1 over 7. So j's are 1/8 of the total, 12.5%. Okay, so notice, sure, I could get there with all this algebra, but once I spot it's a weighted average, this is pretty fast, right? The 42 goes on the diagram. I keep track of the distances. I'm careful to associate the 7 properly with the n rather than with the j. And again, that leads me to the correct answer of B here. Okay, so what do you want to take from this question? Well, I think the key here is to recognize this is a mixed or weighted average question. There's a lot of different ways of presenting those. I could have junior and non-junior employees at a company. I could have 2 different liquids with different percentages of alcohol, that sort of thing. But at the end of the day, once I recognize it's a weighted average, I've got a nice, efficient way to approach it. And again, I end up with a correct answer here of B. All right, great. Let's take a look at the next question. All right, let's take a look at this one. A certain zoo sold admissions tickets to groups of 20 people every 10 minutes from 5 p.m. until 9 p.m. inclusive. Tickets for children cost $7 each and tickets for adults cost $22 each. If the zoo's ticket revenue on a certain day was $5,000, how many adult tickets were sold? Okay, so let me start translating this information here. I notice I have a certain number of adults that are buying tickets and they're spending $22 per ticket, so that's how much money I'm making from the adults, and it's $7 for each of the children. Okay, so that should give me the revenue from adults, revenue from children, and that's gonna add up to $5,000. Okay, great, I've got an equation with two variables. I think I'm gonna need another because I need to solve for A here, so looks like that's gonna be useful to have. So that beginning part of the question, can I translate that? Okay, we're selling tickets to groups of 20 people, so I'm selling 20 tickets every 10 minutes. Okay, great, and that's from 5 p.m. until 9 p.m. inclusive. All right, so if I'm selling tickets every 10 minutes, 60 minutes per hour, okay, I guess that's 120 tickets per hour that I'm selling. So I'll get that noted here, 120 tickets per hour. Okay, now if I was rushing, I might say, okay, well 5 p.m. to 9 p.m., 9 minus 5 is 4 hours, 120 times 4 is 480, great, I sold 480 tickets, but be careful. If I did that, I'm missing this really key word, inclusive. Okay, I want to include the endpoints. So let's see how that relates to this question here. Well, if I think about it, if I map out the tickets I'm selling during that first hour, it's inclusive. So I'm starting at 5 p.m., selling 20 tickets. Then, well, 5, 5:10, 5:20, 5:30, 5:40, 5:50. Okay, so from 5 to 5:50, I'm selling 120 tickets. And the same thing would be true from 6 to 6:50, and 7 to 7:50, and 8 to 8:50. And great, there's my 4 sets of 120 tickets. I've sold 480 tickets by 8:50, right? Inclusive still includes 9 o'clock. 9 o'clock, I'm selling another 20 tickets, so my total is actually 500, not 480 as I might have mistakenly thought. So just a note on this wording, inclusive, that's an issue that we delve deeply into on our counting video, so feel free to check that one out to get a lot more practice with that kind of thing. But long story short, the context of this question, I know, cool, I sold 500 tickets total. All right, so if I'm selling adults tickets and children's tickets, and I have a total of 500 tickets, then A plus C has got to be equal to 500. Okay, well, it looks like a fairly straightforward system of equations here, but these numbers are kind of ugly, right? So why am I including this in a weighted averages mixtures video? If I'm really sharp, I can spot that what's going on here is a mixture situation, right? Essentially what I'm doing is taking a weighted average of 22s and 7s, at least I could think of it that way, if I divide this by A plus C, right? Certain number of A's, certain number of C's divided by the total number of, a certain number of 22s, certain number of 7s by the total number of 22s and 7s. Okay, great. Now, to be fair, if I'm dividing the left side by A plus C, I need to do the same thing over here, but I'll say 500 instead of A plus C because I can simplify that really nicely. 5,000 over 500 is 10. Okay, cool. So if I'm really sharp, at some point, maybe once I've gotten these equations down, maybe even right from the start, I can see what's going on here is I'm finding the average ticket price. The average ticket price is the weighted average of the children's tickets sold, the adults' tickets sold, and that weighted average, the average ticket price, right, the total number of revenue over the total number of tickets sold is $10. Weighted average of 22 and 7 is 10. Once I spot that, I can take this nice algebra-free path that we discussed on the last question, right? I'll give myself this barbell diagram. I'm taking a weighted average of 7s and 22s. How many 7s do I have? Well, that's children. How many adults do I have? That's A. And the weighted average that I ended up with was 10. All right, great. So what does that tell me? Well, I have more children than adults. But how many more children than adults? Well, let me look at these differences. 22 to 10 is 12. 10 to 7 is 3. Okay, the ratio there, 12 to 3 is 4 to 1. Now, we said got to be more children, right? Because the ticket price, the average ticket price is closer to 7 than to 22. I've got more children, so children is 4, adults is 1. And just a little note, very easy to mess that up and to accidentally associate the 3 with C, kind of because they're closer on the diagram. But as long as I'm rooted in the logic, no, more children than adults, that reminds me, children goes with 4. Okay, so what was I trying to answer here? How many adult tickets were sold? Okay, well, the ratio of adult tickets to children's tickets is 1 to 4. So adult tickets are 1 out of 5 total, 20%. 20% of 500 tickets is 100 tickets. Okay, great. So again, just a reminder, there's a lot of different ways to approach GMAT questions. And if you can spot the most efficient way, you're going to be in good shape. You're less likely to make a careless error. Nice to do a question in an efficient way. How do you do that here? Well, as soon as I spot that it's a weighted average, I've got a nice, efficient, algebra-free way to do it. And again, that leads me to the correct answer here of B. All right, let's take a look at the next question.
All right, 2 last things. Thank you so much for making it to the end of the video. If you've made it this far, you're one of those awesome people that's obviously really engaged in this GMAT thing. We would love your comments and your feedback. If there's anything else you'd love to see in our videos, hit us up in the comments. We'll do our best to oblige. Second thing, if you're enjoying it, hit that like button, hit the subscribe button. Helps other test takers like you find our full free video course. You need anything else? You know where to find us, gmatninja.com. Thanks so much. Enjoy this last question.
All right, so we promised a percentiles question, here it is. And after going through all the official GMAT questions, we realized percentiles, not a huge topic, but in theory something that could show up, so we wanted to make sure you're covered. This question also incorporates medians, and we thought, well, this is a quant series, but these statistics topics also show up on the data insight sections. They show up in data sufficiency questions in a way that's pretty similar to how they show up in quant questions, so we thought we'd cover a data sufficiency question as well. All right, so 2 different sections of an economics class, designated A and B respectively, took a final exam. Each student received an integer score from 1 to 10 inclusive. If section A had 50 students and section B had 100 students, what was the median final exam score when sections A and B were combined? Okay, I've got to find the median score. The scores are between 1 and 10 inclusive, so the median is going to be a number between 1 and 10 inclusive. Now, how many scores do I have? Well, I've got 50 students in one section, 100 students in the other, so I've got 150 total scores. So if I were to arrange them from low to high, I want to find what's the average of the middle 2 scores, since I've got an even number of scores here. Well, let's see. if I divide 150 by 2, I've got the first 75 scores, and I've got the second 75 scores 76 through 150. So I can see the average of the 75th and the 76th score would give me the median. So that's what I'm trying to figure out. Okay, so let's see if if statement 1 helps me pin that down. Okay, a section A student who scored a 7 was in the 90th percentile. A section B student who scored an 8 was in the 30th percentile. Okay, so section A, some students scored a 7 and they were in the 90th percentile. So what does that mean, 90th percentile? Well, that means if I'm in the 90th percentile, I scored better than 90% of the students in that section. Just generally speaking, that's what percentile means. If I scored in the X percentile, I did better than X% of the students. Okay, so this person who scored a 7, they were in the 90th percentile. They did better than 90% of the students in this section. There were 50 students in section A, so that person who scored a 7 did better than 45% of the students, pardon me, 45 students. Those people all scored somewhere between a 1 and a 6. Okay, I don't really know what they scored, but it's between a 1 and a 6. And these other folks in section A, I guess there's 4 more to bring me to 50 people. I suppose they could also have scored 7s. Another person who scored a 7 would still be in the 90th percentile. Maybe they scored higher than a 7, I just don't know. Okay, so section B, I could do something similar. I know that a score of 8, okay, that was in the 30th percentile. So they did better than 30% of the people in that section. There were 100 people, so a score of 8 was better than 30 people. So those 30 people each scored somewhere between a 1 and a 7, and the remaining people in the section, I don't know what they scored, except that they definitely didn't score lower than an 8. Okay, so now, is this enough information to say what were the scores of the 75th and the 76th people? So it seems like it's leaving a lot vague, but let me just confirm that I could have different scenarios, I could have different medians. Okay, so let's just assume these people could have scored a 1 through a 6. Maybe they all scored 1s. These people scored 1s through 7s. I don't know. Let's just say they all scored 1s as well. So the first 45, 30. Okay, so the 75th person was in this group. They scored a 1. Okay, and then what's the next score after that? It would got to be a 7. So the median could be the average of a 1 and a 7. But again, I don't know what these scores were. Maybe this person scored maybe these were all 7s. Okay, then the 75th score would also be a 7, and the median would be the average of 7 and 7. Okay, so statement 1 on its own, not sufficient to answer the question. And I'm going to cross out A and D, and we've got to move on now to statement number 2. Okay, no student in section B scored any lower than any student in section A. Okay, so I've got to throw out all this reasoning here. I'll keep it on the board just in case we want to combine the statements at some point, but I'm kind of forgetting that logic for now. All I'm told is that no student in B scored any lower than any student in section A. Okay, that's nice to know the relationship, but it doesn't pin down any exact scores. I have no idea what these people were scoring aside from that fact. So I can imagine a lot of different scenarios for the 75th and 76th scores. Statement 2 on its own doesn't help. Okay, but what if I combine the statements? So how does that change things on this diagram here? Well, if nobody in section B scored any lower than anyone in section A, what does that tell me? Well, I know one person in section A scored a 7. So nobody in section B scored any lower than a 7. So these first 30 here, we said they could be 1 through 7 just based on statement 1, but if nobody scored any lower than a 7, these have to be all 7s. Those 30 scores have to be 7s. They couldn't be 8 or higher, but they can't be lower than 7. They've got to be 7. Okay, and let me just keep pushing to see if there's any other information that this tells me. Well, again, nobody in B scored any lower than anyone in section A, so nobody in section A could score any higher than a 7. If somebody scored an 8, then this 7 in section B would be lower than that. That's not possible. So I can fill these scores in as well. These 1, 2, 3, 4, 5 people in section A all had to have scored 7s. Okay, so people 1 through 45 scored 1 through 6, And then the next 30 people, in fact, the next 35 people scored 7s. Okay, so people 1 through 45, somewhere between a 1 and a 6, 46, and let's see, that's 35 people, so that brings me to score number 80. They all scored 7s, right? These 30 people plus these 5 more, that accounts for scores 46 through 80. Those were all 7s. So based on that, score 75 and score 76 both had to be 7s. Therefore, taking into account both these statements, the median has to be 7. Great, that answers the question, and we're left with C. Okay, so what do you want to take from that question? Well, we incorporated a lot of different elements here, but the new thing was percentiles. How do you deal with that? And just keeping in mind this basic definition. If I'm in the X percentile, I did better than X% of the people in that group. Putting that all together, we get to the correct answer here of C. All right, well that concludes Statistics Part 2. I hope you found those questions informative. And in case you're looking for more stats coverage, feel free to check out Statistics Part 1 in case you missed it. All right, well thanks for watching and I'll see you next time.